When using the optimized path to remediation, the image build template is the only code artifact that requires updating when applying the latest patches. Once the engineers have updated the template, we will follow the steps to track and roll out the patched image. To initiate the process, we will start in our HCP console. Head over to HCP Packer and select our resource, which uses a naming convention to describe an image related to our web server. This will display those parent or child images based on the chosen image. You can dig deeper into the image to gain more insights, but we will move into the channels area of our image. HCP Packer provides an avenue for both automated and manual testing, and we recommend the general usage of channels. Channels enable a way to dynamically reference specific versions of an image without having to modify any code. To show how this process works, we will use a specific version of our image, which has been found to contain a vulnerability, and remove it from our active production use by modifying our production channel. Once we have upgraded our channel to no longer use that version, we can then revoke that version so that no one mistakenly deploys it after the fact. We can also include some notes and even a date when the revocation should take place. Moving on, now that our channel has been updated and the image has been revoked, let's switch over to HCP Terraform, and specifically the Explorer view, where we will focus on drifted workspaces. By combining the drift detection feature in HCP Terraform with the image lifecycle information provided by HCP Packer, we can quickly identify the workspaces with images that need updating. Here, we can see that we have 10 workspaces that have deployed resources which no longer match their configurations. By using this view, we eliminate costly and error-prone manual tracking processes by automating the detection workflow. Clicking into one of the workspaces, we can see how HCP Terraform provides an easy way to group like resources. Here we can see a workspace which has been configured to deploy a web server which is based on our machine image from HCP Packer out to our production environment. The workspace view shows us several essential pieces of information about this environment, like details about the latest apply, how many resources are being managed, and so much more. However, we are currently interested in what we can see in the health pane on the right side, which shows that it has drifted from the configuration specified in the code. We can inspect the details of the reported drift by clicking on the health subsection. Here we can expand the AWS instance resource to see that the referenced AMI ID is due to a newer image being available in HCP Packer than what was previously deployed. Now, beyond just detecting the changes, HCP Terraform also allows us to automate the remediation process. We can easily update the deployed image with the newly patched version by returning to the main workspace view and initiating a Terraform run. We can do this because our configuration already references the image's channel. HCP Terraform will automatically detect the appropriate image version from HCP Packer and perform the rest of the deployment. So we are ready to remediate the unpatched VM and initiate a run. HCP Terraform builds a number of safeguards into the standard plan and apply process. One such example clearly provides the result of our plan, which indicates it will destroy our previously deployed image and create a new one in its place. This allows the platform team to see what would change if they proceeded with the run and provides a chance to cancel the process before any changes have been made if they happen to notice something unexpected. Further, we can apply enhanced safeguards based on the results of the plan operation and avoid the usual change management approval process. The first area shows the results of the run task feature, which allows HCP Terraform to interact with third-party tools to process information based on our Terraform operation and return a pass or failure. In this instance, we see the results from an integration with HCP Packer, which has validated that our image is the most up-to-date version and has not been revoked. There's also a partner ecosystem of more than 25 pre-built integrations with other solutions to verify policies, perform security checks, and even costing exercises through run tasks. Speaking of policies, HCP Terraform natively supports the automation of policy checks through HashiCorp Sentinel and OPA. By performing policy checks, we shift policy checking left to before the violation has been made. We can write policies to enforce rules around image management to ensure that only the correct sizes are deployed or that they're being deployed during the appropriate windows of time. However, we can also audit or enforce policies around anything the provider is aware of. Finally, after reviewing the plan output and verifying the results of the run tasks and policy checks, we are presented with the option to apply our changes. Again, we've introduced another checkpoint to ensure that what is being deployed is safe and approved. No changes will be made without operator intervention in this workflow. Once an engineer has reviewed the previous steps and is ready to apply the changes, it is as simple as clicking confirm. And after that, the new image will be deployed, and you are now using an up-to-date patched image in your production environment.